In this question, you're told that a ball is projected vertically upwards at 18 meters per second, go up, come down, and hits the earth, the ground here, at 42 meters per second. Okay. Another ball is projected horizontally at 18 meters per second. Now, they move in a projectile and hits the floor here at this velocity v. This is what the question is trying to ask us to find. And we know that this velocity has two components. One is a horizontal component. What is the vertical component? Well, we know the horizontal component must be equals to the initial velocity, because this is a projectile motion. In projectile motion, the horizontal speed remains constant, right? Because only the vertical direction is accelerated. Okay. Now, how do we solve this problem? How do we find the V final? Okay. Now, actually, we have two approaches here. Actually, very simple. The first approach is we use conservation of energy. Now, let's take a look at the first approach here. Now, later on, I tell you the second approach. Now, the first approach is conservation of energy. Actually, very simple. Initially, the object here has potential energy and kinetic energy, right? What is the potential energy here? The GPE, right? The GPE, the gravitational potential energy, equals to mgh, okay? mgh. This is the height. Now, what is the KE here? KE here is half mv square, right? So, now the total energy is GPE plus KE. When it comes down, all will be converted to become KE, right? Now, in this case, this ball is projected to the right at 80 meters per second. Do you know that they have the same GPE and KE? Why so? Because energy is independent of directions, right? Now, so in this case, both have same GPE and KE. So finally, they also must be having the same KE as this object, right? So in this case, they must have the same speed, which is 42 meters per second. Okay, if you are not convinced, let me show you the second approach. Okay, the second approach here, which is using the kinematics approach. Okay, now let's look at the kinematics approach. It's very simple. Let's look at the first analysis here. When it's going up and coming down, okay, we use treat upward as positive. We use v square equals to u square plus 2as. The v is the final velocity, is 42, but I put negative because it's going downwards, because I treat upward as positive. That's why downward is negative 42. U is initial speed, initial velocity. Initial velocity is 18, is positive 18 because it's going upwards. Plus 2. A is acceleration, is pointing downwards. Okay, when it's pointing downwards, A is pointing downwards. A is a G, right? It's the gravity as well. So this one is negative 9.81. Okay, the height is h. All right. Now we get h finally is 73.4 meter, right? Now, once we know this height, let's check for this second analysis for this projectile. Okay, we use the same thing, but now we want to find the Vy. Why I want to find Vy is because I want to find V. Because the V is the resultant of Vx and Vy, right? Since Vx I know is 18, after I know Vy, I can use Pythagoras theorem to determine V, right? Okay, so in this case, I just use Vy square equal to Uy square plus 2as because I'm analyzing the vertical component. So initially Uy, what is the initial Uy? This is the initial U. Uy is 0 initially because initially there's no vertical velocity here. Okay, there's no vertical velocity, only has horizontal velocity. This is called Ux. Okay, Ux, that is called Uy. So in this case, Uy is 0 plus 2a. Now I treat downward as positive. Okay, I treat downward as positive. So a s. That's why I take s as 73.4 because they have the same height as this one, right? After I get it, I get Vy is this number. So I do Pythagoras theorem. I get finally answer is 42 meters per second. So what is the answer? So the answer will be D.